Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This is the second installment in the Adventures with Python series, in which we learn Python by building a text adventure game. No prior programming experience is needed, but you should watch the series videos in order. I'll link the first video here and in the description. Let's get started. In the last video, we learned about the string data type, a data type for storing and manipulating text, and we learned how to interact with the player through input and print statements. We wrote this program, shabbyabbyv1.py, which greets the player, obtains a command, and then extracts the first character of the command and converts it to both upper and lower case. Now let's learn how to take different actions based on what that command is. For that, we'll need an if statement. Before I start editing my script, I'm going to save it as shabbyabbyv2.py. I recommend that for each major change, you save a new version of your program. That way you'll still have your old working program in another file. I'll also change the docstring comment at the top to say v2 instead of v1, and I'll put in today's date. On line 14, we obtain the user's command with command equals input. What is your command? Something you may have understood implicitly from writing this program is that the statements will execute in order, from the top of the script to the bottom. And something that isn't always obvious to learners is that we cannot use a variable in any kind of expression before it's defined. So we didn't try to print or ask for an uppercase version of command until after we'd assigned a value to that variable on line 14. You might try moving the code around. You'll get an error if you try to print command or get its first character before you assign it a value with the assignment statement. If I want to take an action based on the value stored in command, the code that takes that action must come after a value is stored in command. Right now, we're doing some text manipulation after line 14. We'll use that knowledge later. I'm going to delete all of the code after I obtain the command. I'm going to change the comment to simply obtain the command. And above obtaining the command, I'm going to describe the current location and tell the player where the exits are. I'll write a comment, describe the current location, and then under that I'll write a couple of print statements. Print you're in the cloister, and print there are exits to the north, south, east, and west. I've put parentheses around the first letter of each direction to let the player know they can use the letter or the full word. I recommend that while you follow along with this video, you use My Dungeon. That way, you're not trying to learn and trying to adapt what you're learning at the same time. Once you're confident with the concept, you can use them to create your own dungeon. Okay, so let's write that if statement. The syntax of an if statement is the keyword if, all lowercase, followed by a condition, and then a colon. So, if command equals n colon. And when I press enter, notice the cursor has come down to the next line, but it's indented. If yours didn't do that, you probably forgot the colon. Type the colon and try again. Any code that's indented under our if statement will execute only when the condition is true. The condition I wrote, command equals n, is a test for equality. That is testing if the value stored in the variable command is equal to the string n. If it is, then the expression evaluates to true. And if it isn't, if the string is anything other than n, then the expression evaluates to false. An expression that evaluates to either true or false is called a Boolean expression. If the expression is false, then the indented code won't execute. It's just skipped. We use two equal signs with no space between them to test for equality. We can't use a single equal sign because that's already used for assignment. What do we want to do if the user typed n? We want to tell them they're in the church because that's where the north exit leads in my dungeon. So indented, I'll type print you're in the church and then print there is an exit to the south. I'm going to add one more print statement. I'll put print thank you for playing, and I'm going to go back to flush left, back to the original indentation. So I have an if statement with some indented code, and then I have some code that isn't indented after that. If the condition is true, the indented code will execute, and then the code under it will execute. If the condition is false, then the indented code will not execute, and then the code under it will execute. So we go back to our sequential flow of control after the if statement, whether it's true or false. Let me just add a comment over the if statement. Move the player based on their command. I'm going to run the program, and I'll type N. F5 to run the program, remember. And it asks what's my command, and I'll type N. And I get the message about the church and the exit to the south, and then thank you for playing. I'll run it again. Now, anything else I type, including the whole word north, will cause the program to skip the indented code after the if. I'll type hello. The program responds with the thank you for playing message. Only the exact input of the uppercase letter N will cause the program to execute the indented code, because that's the only value in the variable command that will cause the test to evaluate to true. That's an if statement. It allows us to break the sequential flow of control into a branch or branches, as we'll see in a moment, based on the values stored in a variable. The flow of control then returns to sequential after the branching statement is finished. We want our program to handle all of the possible directions, plus anything else the user might type that isn't a direction. We could handle the directions with more if statements, for example, if command equals s, print you're in the kitchen, etc. But there's a better similar way to check for the other commands that also allows us to check if the player has typed none of our commands, and that's with a series if statement. Separate if statements are inefficient here. We want one big if block that will stop executing once it reaches the value that the user typed. To create a series if statement, we write elif at the same level of indentation as if. Elif is short for else if, and after that, our next condition. So, for example, command equals s, and then indented code with our print statements, and then we can do another elif for E and another for W. We can write as many elifs as we need. Let me put those in there for the other exits off of the cloister. Now, what about if the user types something other than N, S, E, or W? We can include a final catch-all condition in our series if with the keyword else followed by a colon. The else is at the same level of indentation as the if and elif keywords, and it takes no condition because the else executes if none of the other conditions in the statement were true. So I'll write else colon, and then I can indent a print statement, something like I didn't understand that command. If I test that by rerunning it and entering N, S, E, W, and then a few strings that aren't N, S, E, and W, I can see that the program responds with the correct print statements for the exit I've taken, or I don't understand that command if I've typed anything else. In a future video, we'll modify this so that the game will continue to play until the user enters Q as their command. That will require another flow of control called looping. Before we do that, though, we'll want to explore some ways that we can make our command processing more robust. Right now, the player can't enter a full directional word, such as north, and they can't enter lowercase directional letters. They have to enter exactly uppercase N, S, W, or E, or the program tells them it doesn't understand their command. Let's begin by converting the user's command to uppercase. That will allow us to check their input against an uppercase command only. Right after I obtain the player's command, I'm going to write command equals command.upper open close parentheses. And I'll change the comment to obtain the player's command and convert to uppercase. Recall that upper, when applied to a string, will convert all of the letters to uppercase, but it doesn't change the original string. It returns a copy of the string, but in uppercase. So we need to assign that result to a variable. I don't have a reason to keep the original command around, so I'm going to store the uppercase command back in the same variable. Thus, command equals command.upper. This small change means I can type lowercase letters at the prompt and they'll be treated like their uppercase equivalents. I'll run it and type lowercase s. and it tells me I'm in the kitchen. Now, with what you know, can you think of a way to process the full words north, south, east, and west in addition to the single letters? I'll show you 2 ways given what you already know. The first way is a little bit of a cheat because it won't always work. Suppose I write, either before or after we've converted command to uppercase, command equals command sub 0. That will store only the first letter of command in command. If the user typed the full word north, then it will be truncated to simply N. The same with the other directions. Let's run that. I'll type the full word north, and I'm in the church. But, of course, they could also type no, or nonsense, or never, and that would be interpreted as north, so it's not perfect. I'll comment that line out so it won't execute. Let's try something else. I could write a second set of conditions for the full words, so add 4 more elifs. I'll just add one to illustrate. After the conditional code, after elif command equals W. But before else, I'll write elif command equals north, all uppercase, because recall we converted the player's command to uppercase, and then colon, and indented the same code that I have for N. Print statements telling the player they're in the church and they can exit to the south. Now this will work only for the full word north, so no, nonsense, and never will all get I didn't understand that command. I'll run it and type north, and I'm in the church. But if I run it and type never, the game doesn't understand that command. This works, but it's not ideal because I have a lot of repeated code. I really want to write the condition once for each block of code. Fortunately, I can do that by writing a compound condition. I want to move the player to the church if the command is N, or if the command is north. And Python, like most programming languages, will allow you to write OR statements. I'll change my first statement to read if command equals N, or, it's actually a word, or, all lowercase, command equals north. And I can delete the last elif now. I'll add in ORs for south, west, and east as well. Take note of the structure of the compound expression. On the left of the OR, I have a complete expression, command equals N. And on the right, I have a complete expression, command equals north. Even though it's quite normal for us to say, if command equals N or north, we do not write the expression that way. Python will let you do it, but it doesn't mean what you think it means. It'll always be true. I'll illustrate that in the console. I'll write command equals S. So we know the value in command is S. Now I'll write an if statement written incorrectly. If command equals N or north. Print, you're going north. And it prints, you're going north, even though we know command was neither N nor north. Let's confirm command is still S. I'll type command, and it's S. I'll link a video here and in the description explaining what's going on in case you're curious. Learners make this mistake a lot, and it's difficult to debug because it reads quite naturally and it's not a syntax error. But it's wrong. If we wrote our condition that way, the game would always think the player was going north. Make sure you always have a complete Boolean expression on each side of an OR statement. Now, there are a lot more operators that allow us to write Boolean expressions. With strings, we'll mostly check for equality or inequality, and the operator for that is exclamation point equals sign, no space between them. Although you can check if a string is less than or greater than another string. You can think of less than as alphabetically before, roughly speaking. The operators for checking less than and greater than are the angle brackets. And if we want to check if one expression is less than or equal to, or greater than or equal to another, we can write the less than sign with an equal sign together with no space between them, or the greater than sign and an equal sign together with no space between them. These comparison operators are more commonly used on numeric expressions. We also have another compound operator besides or. We have and. An expression written with an or operator will be true if either of the expressions or both are true. An expression written with an and operator will be true only if both expressions are true. So we would not write if command equals equals and command equals equals north, for example, because it's not possible for command to equal two things at the same time. But we might write an expression such as if room equals equals cloister and command equals equals north, because we might want to take an action only if both of those conditions are true. I have many videos on this channel on Boolean logic if you want to delve deeper into this topic. I'll link a playlist here and in the description. For now, practice with this. Add some commands to the command list such as look, inventory, and take, and add them to our serial if statement. See if you can figure out how to write the Boolean conditions if you convert the user's command to lowercase rather than uppercase. Write a separate program that asks the user to enter a number between 1 and 5 and prints a description of a different monster for each possible number, or asks them for a monster name and prints a description of the monster they entered. When you're feeling confident with writing serial if statements and Boolean expressions, join me for the next installment of Adventures with Python. As always, have fun and keep coding.